Hi, this is Robert from Part Fusion Electronics. 2 weeks ago I did this technical drawing of a design for a camera mount for my Yi Lite Action Camera to Arca-Swiss. So earlier in the week I got a chance to go to the talk Hackerspace, and I was able to produce the model and 3D print this prototype. So this was printed on the Prusa i3 MK3S. It's a new 3D printer we got in the space. It's printed with PLA, and it works really well. There's a few little things I would like to tweak, and that's what I'm probably going to go through today on this video. Show you how I went from the 2D drawing to the 3D model in the OpenSCAD modeling tool. So the camera mount has this bolt that I can put through the hole and kind of push through with the Allen key, and then I can screw that into the camera, and it's nice and firm, a little bit top heavy, but that's to be expected. And then I can kind of screw it here into the Arca mount. It's very sturdy. Like, I think if I really forced it I could break the 3D print here, but that's not the intended use. And then I can open up get access to the SD card quite easily. And then the Arca-Swiss mount can be screwed into something like a ball head screw and attached to something like this type of mount, or you could screw something into a wall or a bracket to have a kind of a permanently mounted position, and then have this movable. So if I quickly remove the 3D printed mount, some of the features I'd like to, or the small modifications I'd like to make, is to, where this little shelf, this triangular shelf is, I was thinking I might take the fillet and have it come down to where this opening is. Just give it a little bit more material to stop this maybe from breaking or getting damaged. The other feature I'd like to do is to make this opening a fair bit bigger, taller, and make it a little bit wider. As I said, the bolt gets in relatively easy, but just be a little bit easier to get in and out. I could also think about having the bolt mount maybe down into some surface here. What I won't do today, but one option I was looking at was maybe extending this shape into more of a square, so that you could mount that way or that way, but it's not critical for what I'm trying to do today. So the OpenSCAD tool, or OpenSCAD, I'm not sure what the exact pronunciation is. It's a tool where you kind of program the how you want the 3D model to create. It's not like Blender where you actually kind of craft the models. So it's got a constructive solid geometry model, so where you use unions and intersections and differences, Boolean operations, to kind of build up your model. You can also extrude 2D shapes into a three-dimensional model. So for this design, I found the best way was to do the 2D to 3D extrusion. So if we take this shape and it was on a like flat surface like this piece of paper. And then we give it depth by extruding up. We get this kind of eye shape. And then if you take your cylinder and you kind of produce the difference between this shape and the cylinder, you get the hole through. And if you take a little kind of cube object and then take the difference of the shape and the cube, you get the opening, and then there's another small cylinder in there because the back of this surface is rounded. And that's, and then there's a small cube that takes these triangle pieces, or opens it up here. So that's the basic process. So what I'll do is I'm going to take down some of the measurements from my drawing, and then we'll use those to create the 2D shape. So with my pencil and ruler, we need to pick a kind of an origin point, a starting off point. So I was using this kind of point, the bottom of the hole on the foot, and we need to then measure the XY coordinates of our points around the shape. So if we start off from the origin to this side, is we go X 19, and then we've no Y change, and then the next point here is 19.2 to go up 2 millimeters. Then we go in from the origin to the next point, which is 13, and then we go up Okay, so I'm going to, the other dimension I want to take is this thickness, which was 21 millimeters. And then we need to kind of know the center point of where this opening is going to be. And I said I was going to make it bigger. So if I say this dimension to here is 9, and I was going to make this dimension here also 9. So that makes, do some mental maths, so 48 minus 18, 30, half of that, 15 plus 9, 22. So this is going to be 30, and its center point is going to be 22. Okay, so I'm going to switch over to the computer screen, and we're going to do the modeling there. So here I've started the OpenSCAD modeling tool. So on the left here in this area we have the text editor. So this is where we're going to type in our code to describe our model. Over on this window here we have a viewing area. So this shows us a three-dimensional view of our model, and we can use the right mouse button and click and drag to kind of rotate, and we can use the the left and the right. Did I get that right? So it's the left to rotate, and the right kind of allows us to carefully pan around. We've also got some buttons here to preview, render, zoom in and out, look from the left and the right, you can also have perspective views. And then down here is a console that will show us some error messages, syntax errors. Okay, so to start off with, we basically type in our code here. So if I want to do an example, if I want to create a cube, I would just type in cube. I then need to give the dimensions of the cube. So let's go 10 by 10 by 10 cube. And then if I press this preview button or this preview button or press F5, it'll draw the cube, and I can then explore and zoom around the cube. I can change its position. One feature I like to do is there's another option we can pass to the cube function, I guess, is we can pass in center equals true. And that will place the dimensions at the center. So it'll be the center point. Let me just run that. And we can see that the cube is placed right in the center of our crosshairs, or of our origin. And I can then draw other shapes, like I can do a cylinder, and that has a height h, and if we make the cylinder 15, and then it has a diameter of 5. We can also use the radius of like 2.5, but for this I'm using the diameter parameter, and then I'll also center that, and then I can render that, and we now see a cube with a cylinder going through it, or a cube and a cylinder together as one object. The resolution of the cylinder isn't particularly good. There's a parameter which we can add, a global kind of parameter we can set. It's called fn equals 16, and then if we re-render, we get a higher resolution cylinder. But we can make that almost any number, 32 to make it smooth, but for what I'm doing here, 16 is more than enough. So if we wanted to have a cube with a hole through it, what we can do is we can come in here and then we can say difference. Then just indent these, then close. We run that. We now have the cube minus the cylinder, so we have a hole that we can see through our cube. So that's a kind of very, very brief overview of how to use the OpenSCAD program. What I'm going to do now is I'm going to delete some of these lines, and I'm going to start trying to model my camera mount. So to start off, we're going to draw a 2D shape, of like the eye shape of the camera mount. So to do that, we use a polygon function. Then we pass in an array of points, and these are the ones I took down on the piece of paper. So if we start off with, we have point 19,0, comma 19,2, 13,8, 13,48. And what I can do is I can close that, and I can preview what I've drawn so far. Rotate it around a little. So this is flat on the piece of paper, or on the surface in the X, Y, and then up is the Z coordinate. But if I keep adding points to the polygon, I'm on 1248. So you can do quite elaborate shapes using this method. These points could be generated programmatically in the software, or it could be parameterized, or you could generate them with like a Python script or another program. You can import DXFs from like an AutoCAD or CAD package. Then, will I get it correct first time? Yes. So there's the shape. It has a very minimal depth just to render it. So what we want to do now is extrude this to our 21 millimeters. So what we use is another function of the SCAD. So we go linear, extrude, height 21, I want to center that. So what that has done is taken our two-dimensional model, given it at a depth of 22, and then centered it above and below the XY axis. So we want this to kind of point straight up. So what we need to do now is then to rotate that. So we have a rotate function. We want to rotate it around the X axis, X towards the Z axis. So that's 90, 0, 0. And then we now have our basic shape. So the operations is that this is the kind of polygon, and then we apply the extrude, and then we apply the rotate. Let me indent these. So we kind of see the sequence of operations. This is the kind of primary operation, and then we perform this and then this. So for our original camera mount, we have a hole going through this, so we want to create a cylinder. So cylinder would a height of, let's go with 60. And the diameter is 6.35 or a quarter inch. Then we center that. And we now see it sticking out at the bottom where we want it to be centered in the shape. So we use the transformation or the translate operation. And that takes an XYZ coordinate, so it's 0, 0. I think we were saying 30. No, it's at 30 is too high. So we want to center around the 48 point, which was 22. Not exactly right, but we're going to subtract this from the previous, the main object. So to do that, if we just take our first operation, do difference. So we want the first object and then subtract the mounting hole. So that goes through there. There seems to be a bit of an artifact with the linear extrusion. You can kind of see it there, but that won't really affect the finished model. So our next piece we want to do is to cut away the bit of the shelf here. So there we're going to create a cube, which is (10 by 15 by, I don't think it, or 9 millimeters high. And again, we'll center that. So we can see part of the cube is at the bottom. So now we need to move it up to about this position here. So again, we use the translate function and go 0 for the moment. We want to translate 0 in the y direction, and we want to translate it to 39 plus 45 is 43.5. Almost. 43.5. And again, we can kind of see a slight artifact, and that's because the top surface is exactly overlapping the shape here, or subtracting from the shape here. So one little workaround we can do is we can just make the whole shape just a touch taller. So if I go in and do plus 0.00, you know, a fraction of a millimeter, then render that, we get a smooth hole. And now what I want to do is to move this along the x-axis. So that's just cutting out this part here. And to do that, we can just update this. So I think the number we need is it 5? No, it's a minus. The minus 17. Nope. Okay, there. Minus 12. So we've got the two parts cut away, and now we need to cut away a cube from this surface and a cylinder. So if we do we know we're going to need to move it up. So let's just have a basic translate, and then cube. The cube is going to be 10 by 12 by, we said 30, because we're going to make it bigger. Center equals true. Look what we got. Okay, and we want to move that -5, and then we want to move it up to the 22. Oh, I think my maths was wrong. Let's go 23. Oh, even wasn't correct. 24. So now we can see our opening. It's there. And our hole going through it. And what I want to do is have the cylinder at the back there. That means that we can get the head of our bolt through. So if we do, we can copy and paste this. Change this to a cylinder. And it's going to have a height of 30. And its diameter is going to be 12. I'm not sure what I've done wrong here. Oh, this shows I can show a debugging feature. Okay. Yes. So what I've done is, if you use the pound or the hash symbol, that basically causes everything that's been executed to be highlighted, and we can see the cylinder has actually been moved forward, so we don't want to do that, so we need to take away the -5. Roll around there. Okay, we can see our finished, well, almost finished shape. What I said is I wanted to open up this hole a little bit more, so that was to take the 12 here, or maybe try 14. Maybe 15. So I think that's my finished model. Looks okay. So what I can do is save the file, mount. Let's call it cameraman 2. Save that, and then if I use the render feature, sorry, it's this one. Oh, render. So that's F6. That does a more intensive modeling process than the preview. We can then use the export to STL file, and we can just go with the default file name, and that now creates an STL file, and that can then be imported into the Prusa tools to generate the G code that we can go and 3D print this updated version. Just wanted to do a quick follow-up. So I've just got back from the TOG Hackerspace in Dublin City Centre, and so this was the one I showed earlier that I printed earlier in the week, and this is the new one I just designed. So they're both nice and strong. The only issue between both of them is here where you can see the lack of support material. Makes it a little bit rough on the insides, but it's not critically important. These are still very usable pieces for the mounting on the camera. Anyway, thank you. Bye.